All right, number 14, we want to determine the location and value of the absolute extreme values of f on the given interval if they exist. We have f of x equals 2 times sine squared x, and we are on the interval 0 to pi, closed interval 0 to pi. Okay, so first we're going to find the derivative of this function, find the critical value, and test the endpoints. To find the derivative, we're going to have to use the chain rule, so treat this like 2 times sine of x, and the sine of x is squared. So we're going to do 2 times 2, which gives us 4. Subtract 1 up there, and we're still going to have 4 sine of x, and then the derivative of sine is cosine of x. So here's our derivative. We're going to set this equal to 0. All right, so this function will equal 0 if sine x is 0 or cosine is 0, which is 2. You would factor it out, but it's these two are already in factors. So the 4 will be inconsequential, but I'll put it for sine of x and then cosine of x. So whenever these are 0 on the interval 0 to pi. So you would divide by 4. And then if you were wanting to solve this, you would take the inverse sign, or they call it the arc sign, of both sides. So it would be sine inverse. And that gets rid of the sign. And then you would have x equals whatever the value you get here. And you would do the same thing over here, but you would do arc cosine. So inverse cosine of, this is the property, and then you would do inverse cosine of 0. Now, for all intents and purposes, this is basically coming from the unit circle, and we are on the unit circle from 0 to pi. So here's 0 going over to pi, and we're looking at the coordinates. So there's the corner points, or the edges of the origin. This order pair is 1, 0, x is 1, y is 0. This order pair is 0, 1, and then this order pair over here is negative 1, 0. So cosine is x, sine is y. There are two values that give us a sine of 0. That would be 0 and pi radians. So if x is 0, we get this equals 0, or if it's pi, we get 0. And then whenever cosine, this is pi over 2. Okay, so in that range, whenever x equals pi over 2, we also get 0. So we have 3 critical points, the 2 endpoints, and pi over 2. And so we are going to plug each of these values in to this function and find out which one gives us the max or minimum. Now, knowing this already, even though this is sine squared, plugging in a 0 or pi will give us both 0. That is the value. When we plug in 0 in pi, the sine, the y value is 0. So I don't actually have to do that, but I can show it to you. Sine squared of 0 and sine squared of pi. I'll use the online calculator just to kind of show you that calculation. If we do 2 sine, let's just say 0, and then I'll put the square here, we get 0, and then if I do 2 sine, we're going to do second pi, and this is squared. Okay, both of them give us 0. That's coming from our unit circle as well. But if we plug in pi over 2, so what we'll get from our unit circle, if we want to look at that, we'll plug in pi over 2. Sine of pi over 2 is going to give us a y value of 1. Squared is still 1 times 2 is going to give us 2. So whenever we do sine 2 sine of pi over 2 squared, a sine of pi over 2 is 1. 1 squared is still 1 times 2 will give us 2. Okay, so we get minimum values of 0, both of these, and a maximum value of 2 at the critical value pi over 2. But just to kind of reiterate that as well, just to show you 2 times sine, and we'll do second pi divided by 2, and this whole thing squared. Okay, and we get an output of 2. Okay, so absolute maximum value, that's the highest value we get, is 2. So the absolute maximum is, let me see, we got different options. Absolute maximum, there is no minimum. It says absolute minimum and the absolute maximum. Absolute minimum is, absolute maximum is, B might be good. Absolute minimum is, there's no absolute maximum, there is no absolute extreme. Okay, so we want option B. Absolute minimum is 0, and it occurs at x equals 0 and pi. Okay. So you separate those with a comma, and then the absolute maximum is 2, and that occurs at x equals pi divided by 2.